Welcome, everyone, to this episode of the Fired Up and Plugged In podcast powered by Emergency Reporting. This is the podcast for all 21st century fire and EMS personnel. I'm Tom Lewis, Enterprise Training Manager and the podcast producer. Joining our distinguished host, Randy Bruegman, is Ken Isman, Clinical Professor at the University of Maryland, where he teaches classes in fire protection systems design, performance-based, and life safety analysis. Ken will share his insight on the science of fire and of fire protection systems. After spending 28 years at the National Fire Sprinkler Association, NFSA, in 2014 he took a position as a clinical professor at the University of Maryland in the Department of Fire Protection Engineering. A noted author and lecturer, Ken has been a speaker at hundreds of seminars, workshops, and conferences, and has written a number of books on the design of fire protection systems, including co-authoring the first edition of the NFPA Fire Pump Handbook. His latest book, Standpipe Systems for Fire Protection, was recently published by Springer Press. Ken also currently chairs the NFPA Committee on Residential Occupancies, which is responsible for producing NFPA 13D and NFPA 13R. Welcome to our podcast, Professor Isman. Chief Bruegman, it's all yours, sir.
Well, good day, everyone, and welcome back to another session of Fired Up and Plugged In. And today it's my pleasure to introduce Ken Isman, clinical professor at the A. James Clark School of Engineering, University of Maryland. He's an educator, an author of numerous publications and handbooks for the National Fire Sprinkler Association and the Society of Fire Protection Engineers, and been a friend of mine for many, many years. So welcome, Ken. It's great to see you.
Howdy. Good to see you as well.
Yeah. How are things in Maryland today?
Oh, things are going pretty well. The students have wrapped up the semester and into final exams at the moment, so we're getting along.
Yeah. Well, you have built quite a reputation in the field of fire protection engineering, and that's kind of what I wanted to explore with you today. It's often the somewhat overlooked, I think, in our profession, the importance that the engineering piece really plays on the day-to-day lives of our community and the people that reside in them, but also in the safety of our firefighting personnel, and pretty important piece. So if we could today, could you just start and share a little bit with the audience about how you became interested in fire protection? Because I think there's a story there. and then provide an overview of how you got here today. I mean, what was your journey?
Yeah, so trying to keep this somewhat limited in time, because we could spend a half hour just on that story alone. You're right, but I was literally born into the fire service and fire protection. Those of your viewers who have been around fire protection for a while might recognize the name Isman. In that my dad was a very active firefighter and eventually fire chief, and president of the International Association of Fire Chiefs a ways back in the 1980s. And there was a tradition when I was born. We were living in New York, and he was a volunteer, and there was a tradition in that department of making the young and newborn sons of the volunteers honorary members of the volunteer fire department. So I was literally made an honorary volunteer firefighter the day I was born. I hung out. My misspent youth was in firehouses, just hanging out with my dad. And I really got involved. I would watch him teach, and he was quite an educator himself. And I would watch him teach about pumps and hydraulics to firefighters and incident command and hazardous materials, and was really interested in all of that as a kid growing up. And tried being a firefighter as a young teenager. They had a cadet program, and I tried doing that, and just realized I wasn't one of those people psychologically that was going to be able to go into a burning building, but I wanted to make fire protection a part of my life. And so talked with my dad about career opportunities, and he had worked a while at the University of Maryland and was very familiar with the fire protection engineering program there. And as he talked to me about it, I thought, that's the way to go. That's what I'd really like to do. So went to school at the University of Maryland, studied fire protection engineering, interned for the U.S. Fire Administration as a statistical database analyst while I was a student. Also interned for the American Petroleum Institute, designing fire suppression systems for petroleum situations. But once I graduated from Maryland, I ended up working in the fire sprinkler industry and just spent 28 years designing water-based fire suppression systems and writing building codes and fire codes, and just trying to teach other people how to do those things better. And spent a lot of time in my career teaching. Realized that I enjoyed teaching so much that as I got later into my career, I decided I really want to do that full time. So I left the design side of the business and went back to the University of Maryland as a professor. And I've been there now 7 years teaching classes in fire protection systems design, life safety analysis, performance-based design with engineers. And I'm just having a blast, just trying to push forward the technology a little bit and make sure our students are strong in their fundamentals of fire, what fire is, and how we can deal with it.
So how many students do you usually have go through your classes every year?
Our class size is roughly 40 to 50 students right now in each of the individual classes. We have around 120 undergraduate students total at the university, and we have about 80 graduate students.
Wow, impressive. Yeah. I had the opportunity to, as we have chatted before, to actually sit through a couple of the classes that your dad taught, and he was an excellent instructor. But that was kind of at the forefront of hazardous materials for many of the firefighters that are watching today. They probably, where we're at today and where we were at then. I mean, he was really an innovator in that whole arena. I mean, he could really see where the need of the fire and emergency services, where it needed to go and how to prepare itself. And he was really at the forefront of really helping to, I think, establish where we're at today. Incredible.
Yeah, well, a lot of people don't realize that, he had this fire protection background, but he was a volunteer firefighter at first. His real job was as an electrical engineer. And so he brought that engineering training and experience and knowledge of chemistry and physics to his firefighting, and realized early in his career that firefighters were being called to help when these hazardous materials incidents occurred, even though they weren't fire problems most of the time. And his chemistry and physics background gave him an ability to understand what the problem was and how to potentially deal with it. But most firefighters don't have that background. And so he started sharing that, as you said, very early in his career, and was one of the few people to really organize that in such a way that firefighters could learn.
Yeah, I think. I mean, if you look back over, I think history will point to him and a few others that actually, I mean, they've saved lives. They've saved thousands and thousands of lives, not only civilians but firefighters, because at the time we just didn't know. We just went out and did what we did, and we didn't know what the exposure and the toxicity was going to do long term to the health and welfare of our people. So we definitely thank him for that, and I know it was rubbed off on you. So so tell us a little bit about how fire protection engineering has changed over the course of the last maybe 20 years since you've gotten into it. And
so a number of things have changed in fire protection. Mostly, we know more about fire now from a mathematical and physics perspective. It's amazing how much we don't know even still about fire, but we know a lot more now. So now that we know a lot more from both a mathematical and physics perspective, we can actually build mathematical models that can predict fire and what's going to happen during a fire. And we can use those mathematical models to both design better buildings and to inform firefighters what's going on real time. The computing capability exists now where we can actually build models of buildings and run them on a real-time basis and get firefighters some basic information if firefighters would find that helpful. And so we need more dialogue, I think, between fire protection engineers and firefighters to understand just what it is those firefighters need in terms of information. We don't want to overload them with information, because that could happen too.
Yeah.
But the other things we can do, we can detect fire better than we could before. If you look back 20, 25 years ago, we were looking at basically you had your smoke detectors and your heat detectors, and that was pretty much our options. But fire gives off other signatures, and we can detect those other signatures in much more sensitive ways today. We can integrate video cameras into a fire protection. Typically, people use video cameras for security, but we can train a video camera to recognize a heat signature from a fire at a great distance away, or the light signature from a fire, or even just the presence of a smoke plume. And so we can detect fires much earlier in the fire scenario, which helps the firefighters just get there sooner and do something about the fire much more quickly. And recognizing all of that, groups like Underwriters Laboratories have set up a center for firefighter safety. And they set it up in Maryland specifically because they want to hire our graduates from the University of Maryland. We are the only school with an ABET engineering accredited program in fire protection engineering on the bachelor's degree level. And so they knew they wanted to hire Maryland fire protection engineers. So they set their center up in Maryland, and they've done that. They've hired a bunch of our graduates, and they're slowly developing technologies specifically for firefighters based on what we know about fire from a physics and mathematical perspective.
And so how does that, let's jump down the road a little bit, smart buildings and smart cities and the ability to capture all of that information. How do we do that?
Yeah, so that's going to probably be the next big leap in engineering in general, not just fire protection engineering, but even now when a building's being designed, all of the individual systems are completely separate. Mm-hmm. Your security systems, your fire protection systems, your electronics in the building, they're all fairly separate. And what we're going to see, I think, over the next 20 years is a merging of these technologies. When you think about a smart building right now, they're putting all kinds of sensors into buildings to make sure the temperature, the humidity, the air movement are all such that we feel comfortable when we're in the building. And so the HVAC systems have gotten very complicated, at least in these big buildings. They've gotten very complicated, and there's all these sensors all over the building. Well, those same sensors could be programmed to tell us something about fire in the building, because the temperature, the air movement, the humidity, those are all going to change in a building during a fire. And since the HVAC people are already putting all these sensors in the building, we should be able to integrate that with the detection system and have a good picture of what's going on in that building from a fire protection perspective. And if we have all of that information in different spots of the building, we can triangulate on where the fire is and give the firefighters better information as they're going towards a building that's on fire about exactly where that fire is. At the moment, best information they get is what floor the fire's on. So they might know in a high-rise building the fire's on the 4th floor, but they don't know much more than that. And we can do much better than that, given an integration of the sensors that are being designed into the building. It's going to take a little more work. We're not quite there yet because the language, the computer language that these sensors use to communicate with each other are very different languages. So the HVAC equipment can't communicate with the fire protection equipment yet. We're going to need to redesign some of those computer languages that are being used to program these different pieces of equipment. But once that's done, and it's going to take a company that really wants to do this to rewrite what they're doing, we can integrate these systems and get firefighters much better information. At the same time, we could also give firefighters information not just on where the fire is, but where the people are in the building, because buildings are being equipped with motion sensors that are being used to turn on and off lighting systems and heating systems. If a part of a building's not being used, they're powering it down to save money and energy. And if we knew that, if we knew at the time of a fire there were people moving in a certain room and now they're not moving anymore, we can direct rescue sources towards those locations. If we can use a security system to set up to count the number of people that have left and count the number of people that are in a space, we can tell the firefighters this space has been evacuated already. You don't need to use search and rescue efforts there. But this space over here, there's 3 people we can't account for. So there's this kind of technology that can be pulled together to just help firefighters do their job just a little bit better.
Yeah, it's just really fascinating if you think about how it will change the essence of our profession over the next 30 years. If we have that type of information and can download that to the responding units at our dispatch centers, it's going to change the way we deploy, what we deploy, and we'll be much more precise in our ability to engage in that event than we are today, and it's going to make our firefighters much safer. Incredible.
Yeah, that's definitely the goal.
Yeah, well, let's hope that happens in our lifetime. I'd love to see that. So we've had a lot of discussion in the past about residential sprinklers and the effectiveness, and if you look at just the trend lines of communities that have used sprinklers, the resistance in many areas from our builders of wanting to engage with them, but I think that we have maybe a new arrow in our quiver, if you will, and that is the environment. We know, research has proven that the use of sprinkler systems are very effective in reducing greenhouse gases and toxic runoffs, and not only in just protecting our firefighting personnel, but also the people that are residing in the buildings. So what's your thought on that? How can we move this needle so that we can get the building industry to begin to embrace a proven technology? It's been around a long time.
Right.
Right.
Yeah, it's been probably the most frustrating part of my career. The residential sprinkler was first brought to the marketplace in 1981. And so here we are 30 years later, and we're still having a difficult time getting it incorporated into the single family dwelling environment. It's basically been incorporated now fairly well into the multifamily environment, and the hotel and motel and lodging industry has embraced it. But the home builders, really at the single family home level, have just not embraced it. And I've been trying throughout my career to figure out, that's the magic question, is how to get them to embrace it. And I think there are 2 things that need to happen. I think it's got to happen on a 2-pronged approach. And the first is, I think the public's just going to have to demand it. Yeah. We saw the same thing with airbags in motor vehicles. The technology existed for airbags for a long time, but until the public really wanted airbags, the car manufacturers were mostly resistant to putting them in. And it wasn't until they started putting them in on a voluntary basis, and the public said, yes, we want those, that then the government felt strong enough to step forward and say, okay, then we're going to put it into our codes, the regulations that the federal government uses. I'll call those codes in a very loose sense, for the analogy. But it was only after the public embraced it that we were able to get airbags actually written into the federal regulations on the equipment a car has to have. And I think something similar is going to have to happen with residential sprinklers. The public's going to need to have that desire for it. And that's tough. That means we have to educate the public. There are somewhere around 2 million new homes constructed every year. And somehow we have to get out to those 2 million families that are looking to buy single family homes. They've got to start asking the question. And it's a slow process. It's a process. We need to have some kind of a council to figure out how we're going to do that better, because I just don't think we've done that really well. We've tried. I mean, there are organizations like the Home Fire Sprinkler Coalition that are trying, but it's just a really rough, difficult way to convince people. At the same time, we've got to still work the codes and standards as much as we can. Since the late 1990s, there have been requirements in the model codes to sprinkler single-family dwellings.
Mm-hmm.
But when those model codes are adopted at the local level, those sections are generally thrown out by the local authorities that are writing their codes. And we need to stop that from happening. And the fire service needs to get involved. They need to become politically active. And that's not a role that the fire service has traditionally wanted to play. They really haven't wanted to get involved in politics, but that's what it's going to take. There are 2 states that on a statewide level have mandated the use of residential fire sprinklers in new single-family home construction, and that's Maryland and California. Those are the only 2 states. We tried in some others. We actually got it through the process in Pennsylvania, and then administratively some pressure was put on some people and it was taken out administratively. In New Jersey, we actually got it through the code legislative session, but then the governor vetoed the bill that would have had the fire sprinklers in their statewide code. And so we need to be active politically. We need to let our elected officials understand, regardless of which party they're in, this is not a party issue. This is an issue of life safety for the people and protection for the firefighters.
Right.
This is a situation where, firefighters die from mostly stress. And it's what killed my dad. My dad died of a heart attack. That was not while he was on the job. It happened to be on vacation when he had the heart attack, but the heart attack was brought on by the stress of his job on a day-to-day basis. And there's no question that when you have residential sprinklers in place, the stress on the firefighters in dealing with the fire's still going to happen. But the stress on the firefighters is so much lower when they arrive on the scene and there's one sprinkler open and it's controlled the firefighter. That's a completely different stress situation than when you've got a fully involved single family home when you arrive on the scene. So we need to address this, as you said, on an environmental level, but also on a firefighter health and safety level. Firefighters need to understand that and get involved in the process and make their elected officials understand that we have the technology to solve this problem. And the problem's happening 300,000 times a year in the United States. So it's not hard in any jurisdiction to point to, we had a fire in that single family home and the outcome would have been different if they'd have had fire sprinklers.
Yeah. Yeah, I agree. I think we really need to collectively redesign our marketing strategy. And I think that the new generations that are coming up, I think will have an opportunity to really focus the climate piece on that. But I think if all the national organizations as well as organizations throughout the U.S. are speaking off of the same sheet of music, I think we can move this needle.
Yeah, and I guess another way to move the needle might be, if I recall correctly, and I don't pay as much of attention to this as I should, but I believe there was a death of a firefighter in Connecticut last week at a single family dwelling fire. And I think another way to move the needle might be if that firefighter's family actually sues the home builders for preventing the technology from moving forward. Lawsuits have been used in the past to move a needle in terms of an adoption of technology. And you could definitely make the case in Connecticut, because I know, having lived there in myself many years ago, we tried to pass legislation to require single family homes to be sprinklered, and it was blocked by the home builders in the state. And so at some point in time, there's got to be a consequence for them blocking this life safety technology from moving forward. And it might be interesting if we follow up and say directly, this firefighter's death was caused by fighting a fire in a single family dwelling. And there's no need for having to face that kind of fire situation when we have an answer to that problem readily available.
And you could probably go back all the way to when the first code adoption that required sprinklers for residential, the national codes, were applied in that state, and say anything built past 1990 or whenever that code was adopted should have had sprinklers. So any fire after that, it should be on the builder or on the elected official.
Right, and that's a tough thing to do, to sue an elected official. So that's why, and I'm not a lawyer. I should preface my statements by saying I'm not a lawyer. But I've watched the law evolve over time, and other lawsuits like that have been effective. That's why the lodging industry now embraces fire sprinkler technology, because in the 1980s, there were a whole bunch of fires in hotels where the hotel owners were sued because they didn't have sprinklers. Yeah. And they even tried to use the excuse, well, the code didn't require it. And the judges in those cases threw out that argument, said, no, you can't use that argument. This is state of the art of what's available. You should be looking to protect your guests with what's state of the art and not necessarily just the minimum that the code requires. And so in the MGM Grand fire, there were 83 deaths, I believe. And there was a more than $100 million lawsuit that was settled based on that fire and fire sprinklers not being available. Right after that was there was a fire in Westchester. Westchester County, New York, in a Hilton. And then right after that, there was the fire in Puerto Rico. The name of it just went out of my head, but there were 87 deaths in the one in Puerto Rico, and there again, more than $100 million lawsuit was settled on that fire based on the fact there were no fire sprinklers in that hotel, and the lodging industry woke up and they said, you know what, this is a technology we need to embrace. And today you don't see those kinds of fires happening in hotels anymore. That problem has gone away. And we've got to figure out how to do that with single family homes.
Yeah. And we have to figure out, since we have so much building stock already built, a more effective means to retrofitting those in the future as well.
Yeah, that's going to be a little trickier because of the holes you got to drill in the house to do that. But it's not beyond our abilities. There are ways to do it. And you can do it as you renovate homes. You can do it as homes turn over. There are ways to approach that. But I think we got to tackle the new construction first, and then get at the existing construction a little slightly different angle.
Yeah. How do you look at fire protection engineering and community risk reduction? Yeah.
So. That's another podcast. We could probably spend an hour talking about that subject. But fire is a challenge to any community, and as engineers, we've developed ways to mathematically approach that challenge. We can study risk from a mathematical perspective by saying, okay, risk is really the product of frequency times severity. The word wouldn't come into my head. So, frequency times severity. So you can use models and tools to study different risks and figure out where do you best put your resources so that you get the most effective reduction in risk. And we've done that on a basis. I teach my students how to do that when they're designing buildings, to say, okay, what are the risks that happen in these buildings, and where do you effectively put your firefighting resources to try and address the biggest risks or the biggest challenges. We can do that on a community-wide basis as well. And so some of those risks are fire, and engineers can figure out how to deal with those. But we can use those same mathematical models to develop a way of looking at any risk within a community and figure out where the big challenges are, and then direct our resources towards helping to solve those challenges, and make a community more resilient. That's the buzzword in our industry right now. Is
Yeah, it is.
If you can reduce those risks and bring the resources together to deal with those risks, then you make the community better able to bounce back from any particular incident or event. I watched what happened almost a little over 20 years ago now when Hurricane Katrina hit New Orleans. Mm-hmm. And you saw a situation there where New Orleans just wasn't resilient. They weren't able to deal with all of the different challenges that came their way based on that hurricane. Some that were predictable, some that experts hadn't even thought about that were going to become challenges. But you can use stuff like that as a case study to say, okay, where are our communities vulnerable? What can we do to change that vulnerability? Mm-hmm. And the tools are all there in engineering. We just need someone there to apply the tools. And I've long been an advocate of trying to get fire departments to understand that hiring a fire protection engineer can be a good thing. That fire protection engineers have these tools that they can use to help with analyzing these risks and dealing with community risk reduction. But a lot of fire departments don't see that value. To those fire departments, I would say, well, you should at least engage with a fire protection consulting firm, at least on a part-time basis, to try and review these situations, because we can bring a lot of these tools to bear and try to pinpoint. In every community, it's going to be different, but we have the tools. We can analyze the situations and identify those targets that we can put some resources at that will be helpful in the long run into making the community more resilient.
Well, I think you bring up a point that I hadn't considered about expanding the role of your fire protection engineer. I've had fire protection engineers in several of my organizations, and they were pretty much focused on, plans review and making sure we were building buildings right. But I think there's a definite crossover about their level of training and perspective to go, let's look at the community as a whole, and where are our shortcomings? Where are we less resilient than we should be? And using that level of expertise, frankly, I hadn't thought about that, but I think that's an excellent idea. Because it really is all about building resiliency in your community. I mean, California is a great example of that, living there for, almost 17, 18 years and watching how it bounced back, after every fire season, and the resources that they have developed, but also just the ability to come back from significant events like that. They have built up a lot of resilience, and it's based upon a lot of the practices that you just talked about. So good food for thought for fire chiefs to begin to expand their fire protection engineering process to look at the entire community. So what do you think about next 30 years? What do you think your profession is going to look like?
Yeah, well, we'll continue to learn more about fire. We'll continue to be able to describe fire better to people, and hopefully, as we say, we'll be able to integrate fire protection with these other building systems. And I think there's going to have to be a tremendous leap forward, not only in building systems with fire protection, but also, as you mentioned, wildfire. We're going to have to make a leap forward in dealing with the wildfire problem. We're working on that on two different fronts at the University of Maryland. We're doing research trying to understand just what causes wildfires to grow and move the way they do. And clearly it's some kind of combination of terrain and wind and fuel and topography. But no one's been able to completely explain all of that yet. But our goal is to have two kinds of computer programs available in the future to deal with wildfire. One is when a wildfire has started, to deploy a bunch of drones to gather information on temperature, wind velocity and direction, topography and fuel, and then plug that into a model and to be able to predict for the firefighters, okay, here's where the fire is now. Here's where it's going to be in 2 hours. So you can deploy your forces to be able to deal with where that fire is going to be 2 hours from right now. So it's kind of a real-time helping to fight the fire kind of situation. But the other kind of computer programming we're working with on the wildfire basis is to start looking at areas and planning better how we can do this interface with human activity and the wildland. We call that the WUI, the wildland urban interface, and how we can build that interface in such a way that it will be less impacted by a wildfire if a wildfire occurs. And that's a little trickier to do, but we're working on that. And so I'm looking forward, maybe 10 years forward from now, we should be able to do that much better than what we're doing now. We've got research going on right now at the university to help understand that a little bit better and understand that interface. So we're hoping that those programs actually lead to better wildland management. I know that's been a big source of debate in terms of how we manage the wildland, and then how we build into that wildland space, and the kind of materials we use to do that construction, the kind of barrier we put between the human interaction and the wildland, and all of that will hopefully get a lot better in the next 10 years. And the rest of it's going to be, I think the advances that we talked about in terms of smart buildings and just trying to get all these different systems talking to each other. I see that happening hopefully in the next 10 or 15 years, which will probably be beyond my career time as a fire protection engineer, but hopefully while I'm still alive, these changes will be happening.
Yeah, it was interesting. We had a fire in 2017 when I was the chief in Anaheim, and I think we lost 80 homes in about an hour between us and 2 or 3 other jurisdictions. But it was interesting as I went back and looked at because we had fires about every 4 or 5 years, significant fires, and it was exactly in the same location. And so I started to research a little bit about, do fires happen over in the same area more times than not? And nationally they do. We actually know where a lot of the fires are going to originate every year. They repeat themselves in a cycle. It's very interesting. And so we actually had submitted a grant to the state of California to actually design a vegetation sprinkler system that we could tie into our municipal system and pump into, that would go along the ridge line of where we knew the fire was going to hit every time. Because that's where the wind direction is, the topography. We didn't get that grant, but I still think it's a viable idea for many areas, that we know where ridge lines are, and that's where the fires always, transcend and then impact neighborhoods and start their run. And so I think we have to use all the technology and not limit ourselves just to. But I do agree. I think the vegetation management is a significant issue. I think we have to get a handle on that as well, because California is a great example. I think they have 65, 70 million dead trees. You can't protect against that. Yeah, too much fuel. So we're kind of upping up on our time here a little bit, but I just any final thoughts for the audience today as they're looking at fire protection engineering and for their organization, or maybe there's a young firefighter out there that says, I'm intrigued.
Well, my ulterior motive in doing this was to get people thinking about fire protection engineering and hoping that firefighters who are looking for a slightly different way to approach fire protection to come to the University of Maryland and study fire protection engineering. Yeah. Or if firefighters have kids like me, I'm the son of a firefighter. So any kids of firefighters, sons or daughters, we're looking for everybody we can get to become a fire protection engineer. If you like math and you like science and you like fire protection, we are the perfect marriage of all of those concepts. And we desperately need more fire protection engineering students. Every one of our graduates gets at least three job offers, and they get their pick of jobs. And even in this environment, that's a good situation to have. But it means that there's lots of jobs going unfilled right now. So we need more people to study fire protection engineering, and the future is very bright for fire protection engineering. That's ultimately the reason I said yes to doing this podcast, is to try and drive that idea home to folks that come to Maryland and study with us.
Yeah, well, I think that's number one. I appreciate the work that you've done there and continue to do. And if we look to the future with all of the technology revolution that we're about ready to experience and are experiencing already, we're going to need significant engineering help in the future in our organizations. And so we're going to need good fire protection engineers. So I would also encourage young firefighters or the kids to look at going into this field. And there's not a better place than the University of Maryland to do that. So. So Ken, thanks so much for being with me today. I appreciate it. Great insight, and look forward to having you back in the future, and we can delve into a little bit more of fire protection engineering at that time.
Great. Well, thanks for having me on. I appreciate it.
Thank you. Okay. Not too bad, huh?
Yeah, it went well.
Yeah. So Tom will put it all together in the next week or so, and then he'll send you a copy of it. So.
Okay.
Yeah.
Great.
Yeah, I appreciate you doing this, and think about what you want to talk about next time, because we can do another specific show on, if you want to do it from, actually the university, and you could maybe highlight some of the stuff you're doing. You could kind of do a walk around or something.
We could do that. We could set something up in terms of we're doing some work with for the National Forest Service on some of this wildland stuff I was telling you about, where we're looking at how fire moves up, given the topography, either upslope or downslope, and given wind direction. So we've got kind of a small wind tunnel that we've built, and we built a small hill basically with a small scale trees on it.
Yeah.
We're trying to investigate that. It's really fascinating because when I came into this 7 years ago, I'd really thought a whole lot about wildland fire. I came to the University of Maryland. Somebody asked me the question. They said, what do you think causes forest fires to move through the forest? And my answer was convective heat release. That's what causes fire to move through buildings. It's convective heat release. Maybe with a little bit of radiation, radiative heat release, but it's really convection that's moving the flame front forward. And they said, nope, we thought so too, but we've done the math and we've figured out, no, something else is driving this fire forward, and it's not convection and it's not radiation. Something else is happening. And it's taken a while for us to figure out what's happening, but what's happening is that the fire's releasing firebrands, just these little small embers of fire that are getting aloft and then getting deposited somewhere ahead of the flame front. And they're starting little fires ahead of the flame front, and that's helping the fire to grow faster than just the convective heat release can explain. And so now we're at this point where we're saying, okay, that's what's driving the flame front forward so quickly. So if we can, at that interface, build materials where those embers are not going to start another fire, then we're going to effectively slow down that fire when it reaches the interface with the urban environment. So that's where some of our research is going right now. So we've got these research pods that we're using, where we're studying the effect of embers on different building materials and just trying to figure out what are the better building materials that aren't going to allow these embers to speed up that fire. And we're not going to be able to actually control what's happening in the forest itself. But once we get to that interface, if we can build better buildings at the interface, then we can slow that fire down when it gets there. So we've got some of that research that's going on that we can show folks. So that's kind of boring sometimes to look at we made a standardized way of characterizing an ember, and so we've got these standardized forest fire embers that we're using, and we're trying to evaluate on different materials how they're actually interfacing with the materials. So sometimes it's boring to just look at an ember just smolder there for an hour and a half, but we've got some of those study things we can show, and then we can just show off some of the fun stuff we do with fire. We build a fire tornado, which is mostly we've been doing it for fun, just to show people, hey, look, you control the air movement into a fire, and you can set it up swirling as a vortex. But what we found is there's some actual advantage to studying the fire tornado, that it does happen in nature. So understanding how it happens, it can happen in both an urban and a rural setting. Just looking at how the wind moves through a city and moves around buildings, it can set up a situation where you have a fire tornado actually in an urban environment, as well as in a completely rural environment. We've seen them happen in nature as well. But it also has some industrial applications, in that if you can set up a fire tornado, it's more effective burning of the fuel. It's a cleaner burning of the fuel. And so you can actually get better energy production out of the same amount of fuel. So from a power generation standpoint, the fire tornado is interesting to study. And we've also learned that if you really carefully control it, you can get this fire tornado, which is normally a big red-orange flame. You can get it to snap down to a very small blue flame that's incredibly efficient in terms of complete combustion with no soot. And we're currently studying that to deal with oil spills on the water. If we can burn off an oil spill with a blue fire tornado, what we call the blue whirl, rather than this orange-yellow flame that emits a ton of soot into the atmosphere, it can be environmentally a much better way to clean up a fuel spill than just burning it off, just setting fire to it. So we're now playing around with these industrial applications, which have nothing to do with putting fire out. These actually have to do with keeping fire going. But our knowledge of combustion is leading us in some of these interesting research directions. So we can go into the lab eventually. Right now, we can't have visitors in the lab because of COVID restrictions. But as soon as those get lifted, I can, because I'm considered a visitor. As a clinical professor, I don't do the research myself. We've got other folks doing the work. So I'm considered a visitor. But as soon as the COVID restrictions are lifted, I can go back in the lab with a camera, and we can broadcast some of that on a podcast if you want.
Yeah, no, that'd be fascinating. I think that would be excellent to do. So yeah, let me know when that's available, and then we'll get something set up and figure out how to do that.
Okay, sure.
All right. Well, appreciate it. Hope you have a good rest of the week.
Thanks. It's going to be grading a lot of papers and a lot of final exams.
Yeah, that's that time of year, huh?
Yep.
Well, good. So anyway, appreciate it.
Yep. Take care.
Okay, talk later.